Yeah, welcome back. In this class, we are going to design a very important topic which is regarding the unit number 2 and unit number 2. The topic name is how to design any logic using complementary MOS transistor and Nmos transistor and Pmos transistor. First of all, we will talk about the complementary MOS transistor and later we will discuss about Nmos and Pmos. Is it clear all of you? Yeah, welcome to Cmos logic design. Here I am going to tell a very simple trick how to design any logic using Cmos. If you remember only this keyword, what is that keyword? PAP keyword. What is meant by this? Pmos transistor should be either in AND logic or NAND logic. It should be connected in parallel. Okay, now you can observe very clearly that in CMOS logic we are having two networks. One is pull up network, another one is pull down network. Is it clear? Always we know that pull up network is a PMOS transistor and pull down network is a Nmos transistor. If you observe that the gates of pull up and pull down network should be tied together and a common input is given. Okay, the drains of pull up and pull down network should be connected together and a common output is taken, and the source of pull up network is always connected to VDD and the source of pull down network is always connected to VSS. Is it clear? Now once again I am telling that please remember this keyword. What is that? PAP keyword. PAP in a sense, the first P represent PMOS, the second A represent either AND logic or NAND logic, and the third last one, the P represent a parallel one. Is it clear? Now you can observe that how to design any logic using CMOS with this simple concept. Is it okay? Now observe that let us consider this is an example I have considered. We have to design a 2 input NAND gate using CMOS. You can observe that since 2 inputs they have given, therefore how many transistors required, either PMOS and NMOS? Absolutely 2 PMOS transistors and 2 NMOS transistors are required. Now you can observe how to design it. I already said that in AND or NAND logic you can observe that the PMOS should be connected in parallel. Therefore I have considered PMOS transistor. This is one PMOS transistor and this is another PMOS transistor I have considered. These two should be connected in parallel. Since 2 inputs are there, therefore 2 transistors I have taken, and it is given to whom? Absolutely VDD. And if you talk about NMOS section, exactly opposite to that. Is it clear? Since PMOS is in parallel either in AND or NAND, NMOS should be in series. Is it clear all of you? Then very simply you have to connect like this. Is it clear? Then this is A and this is B. Okay, and it becomes what? VSS. Then the output is taken between pull up network and pull down network. You can call this as an output. Is it clear all of you? This is very simple to design a 2 input NAND gate. Further example we will consider. You can observe very clearly here. Now you can observe how to design a 2 input NOR gate. Is it clear? Now you may know that in AND or NAND PMOS should be in parallel, then in OR or NOR PMOS should be in series. Absolutely. Now you can observe that I am going to consider 2 PMOS transistor. It is going to be connected in series. I hope that are you clear. Let us consider A, B. Now you have to design a NMOS transistor exactly opposite. Here they are in series. Okay, then you have to design in parallel. Absolutely. Then you have to design NMOS transistors in parallel. Is it clear of you? Then it becomes VSS and this is A transistor and this is what? B transistor, and the output is taken between these two. I hope that are you clear? This is VDD, don't forget this. Are you clear? This is how to design a 2 input NOR gate. Then we will take further a complex circuits. You can observe very clearly here. Now you can observe that 3 input AND gate we have to design. Let us understood this one. AND gate they are telling that. Okay, first of all we will design 3 input AND. We know that in AND or NAND PMOS should be in parallel. Therefore I am considering 3 PMOS transistor. 1, 2 and 3 PMOS transistors in parallel. This is 1, this is 2 and this is 3. Okay, and it is given to what? VDD. Okay, and 3 NMOS transistors should be in series. Absolutely. 1, 2, 3. Sorry for that. 3. Is it clear? This is VSS. You can observe this. Okay, and the output is taken between these two. Okay, this is A, this is B and this is C. A, B and C. Now you have to observe that they set to design AND gate. That means Y is equals to A, B, C. Very important point, in your Boolean expression, if there is no complement here, okay, in your Boolean expression, if there is no complement, then you have to connect what? An inverter. Is it clear? But don't forget, here the inverter should be also what? A Cmos one. Therefore you have to design an inverter here. Absolutely. Then you have to design an inverter here. Okay, then this output is given as input here, then it becomes VDD and it becomes VSS, then it becomes what? AND gate. I hope that are you clear, all of you? In this manner you have to design. Very important point, if there is no Boolean expression, if there is no complement in your Boolean expression, you have to use what? An inverter, opposite one. Remember very carefully. Then you can tell some very complex circuits we will see here, then try to tell that one. Yeah, now you can observe that how to design AB plus C here. Okay, now very important point, how many inputs are there? Absolutely 3 inputs are there. Among them 2 are in AND operation and one is what? OR operation with that. Is it clear? Therefore the Pmos, 2 Pmos should be connected in parallel. Let us consider these two, A and B. Now you can observe this is A and this is B. Okay, yeah, this is completed and C is required. It is in OR operation, therefore it should be connected in what? Series. Absolutely, this is C and exactly opposite here, these two are in parallel, therefore these two should be in series here. A, B, this is A, this is B and this is in series here, therefore it should be in parallel here. Is it clear? Then it becomes what? C and it is what? VSS. Then the output is taken here. Don't forget, here in your Boolean expression complement is given, therefore absolutely need not any inverter. I hope that are you clear. This is about y is equals to AB plus C whole complement. Now you can observe the another complex circuit. Yeah, now can anybody try to tell how many number of inputs are there? Yeah, sorry, not 2. There are 4 inputs. You can observe that here A is there, it is an input. B is there, it is also an input. Don't forget, A complement and B complement is also the inputs. Is it clear? Absolutely. Is it understood? Therefore we have to consider how many transistor? 4 Pmos and 4 Nmos transistor, and you can observe that here the first 2 AB are in parallel and the next 2 A complement, B complement are also in parallel. Then these two are in what? Series. Is it clear? Then you can observe that I am going to design this one A and B. These two are in parallel. Now I am giving to VDD. Now you can observe A and B, another 2. Okay, and it should be in series. Absolutely. This is, observe very carefully. Now you can see this is what? A complement, it is an input. It is what? B complement, it is an input. Now you can observe that the what we'll call Nmos section. Okay, in Nmos section, if you observe that these two are in parallel, therefore these two are in, these two should be in series. A, B, A, B, and these two are in parallel, therefore these two should be in series. Absolutely, A and B. Sorry, that it is an A complement and it is a B complement, and these two are in series here, therefore these two should be in parallel. Then it becomes what? VSS. I hope that are you clear. Any inverter required? Absolutely, inverter is required. Why? Because there is no complement given in the Boolean expression, therefore inverter should be definitely required. Therefore I am going to use a different color for that. Okay, there we required an inverter here. Then this output is given as input, it becomes VSS, it becomes VDD. I hope that are clear. Now it becomes Y. Is it understood? Okay, absolutely. Now we will see some. Now we are going to design a special gates. What are the special gates? XOR and XNOR. If you observe that very carefully, if I want to design an exclusive OR gate, okay, then I have to design this. Since there is no complement present in our Boolean expression, therefore I have to use what? Inverter. Is it clear? Now understood what I am trying to tell here? Okay, if I want to design an XOR gate, okay, I should use this Boolean expression, and there is no complement given here, therefore I have to use inverter. Is it clear? Now will you please tell me, if I use an inverter, then it becoming an XOR gate means without inverter, what is that? Yeah, nobody are having any idea? Yeah, absolutely. It is what? XNOR gate. Why? Because don't forget here what I am trying to tell. Observe very carefully. I want to design an XOR gate. Since there is no Boolean expression, then there is no complement in my Boolean expression. Therefore, I have to use what? Inverter. Therefore, if you observe that after inverter you are telling it is an XOR gate means before inverter what is that? XNOR gate. I hope that are you clear. This is the logic. If you want, you can observe very clearly, and if you want to use, that means if you want to design an XOR gate, use the Boolean expression of XNOR, then it becomes XOR. That means if you want to design an XOR gate, you have to use the Boolean expression of XNOR, then it becomes an XOR. Similarly, if you want to design an XNOR gate, use the Boolean expression of XOR, then it becomes what? XNOR. Okay, it is one type of method. If you use this method, two transistors are going to be reduced. Otherwise, you are adding two transistors extra for your design. I hope that are you clear. Why? Because you are going to design with a complementary MOS transistor. Then you can observe that I am going to use the Boolean expression of XNOR to design an XOR gate, and vice versa. Is it clear, all of you? Now you can observe that. Now you can observe that I am using XNOR Boolean expression to design what? XOR. Now you can observe that AB, once again the same thing I am going to consider here. AB, okay, these two are in parallel. Okay, this is A and this is B. Okay, and you can observe one more parallel combination are required. What is that? A complement. What is that? B complement. Okay, these two should be in series. And Nmos section I will try to draw with a different color. Okay, Nmos section you can observe that. Okay, these two here in parallel, therefore these two should be in series. A, B, this is A, this is B, and these two should be in series. This is A complement and this is what? B complement, and these two should be in parallel. This is VSS and this is VDD. Then if you observe that actually if you want to design XNOR, okay, here this is one, there is no complement present here, therefore actually you have to use an inverter here. Okay, after inverter you are telling it is what? XNOR. That means before inverter it is what? XOR. Is it clear? Therefore I will use up to here itself. Okay, I will use up to here itself. I hope that are you clear. Then I will tell that I am not using this one. Then I can tell that by using XNOR I can tell that it is my XOR. Is it clear? Similarly, if I change the inputs, let us consider A complement into B plus this is A, let us assume it is B complement. Similarly, A complement into B, okay, plus let us assume it is A into B complement. Then I can tell that I have used an XOR. Okay, and what is an output? Can anybody try to tell? XNOR is an output. Is it clear? No, if you want to design XNOR itself, then what should you have to do? You have to connect with an inverter. Why? Because there is no Boolean, there is no complement in your Boolean expression. I hope that is it understood, all of you. Okay, in this manner if you design, you can save two transistors. Okay, then final expression I am going to tell that. Okay, let's talk about this. Now let us consider design a Boolean expression y is equals to, okay, y is equals to A plus B, okay, into, okay, C plus D whole complement. Now you can tell what should we have to do. Four inputs are there. Absolutely, these two should be in series, these two should be in series, and these two should be in parallel. Then you can observe that this is A, this is B, this is A, Pmos transistor, this is B, A, B. Okay, series is completed and another series should be maintained, and this is what? C, and this is what? D, and these two should be in parallel. These two should be in parallel. Is it clear, all of you? This is VDD. Now if you talk about Nmos section, since these two should be in series, therefore here these two should be in parallel. This is A and this is B. Okay, absolutely A, and you can observe this is what B, and similarly these two should be in parallel. This is what C and this is what D. Okay, then these two are in series, then you can tell it is what VSS, and you may tell this is your output. Is there any inverter required? Absolutely not required. Why? Yeah, there is a complement given in your Boolean expression, therefore this is your output. Is it understood, all of you? Okay, still if you are having any doubts for any Boolean expression or any logic gate, if you want any doubt you may ask. I hope that are you clear. Thank you very much. Have a nice day.